Hello students. So this is your +1 chemistry class, and yesterday video we have started chapter P block elements. We have covered their physical properties. In the physical properties their electronic configuration, general electronic configuration, as we have discussed. Their general electron configuration is ns2 and p1. In the p orbital only one electron is present, or in s two electrons are present. In the continuation of that last video, next is the ionization energy. Ionization energy is the energy required to remove electron from the valence shell. That amount of energy is known as a ionization energy. And 13th group elements have a low ionization energy as compared to group 2. Group 2 means alkaline earth metals. Why 13th group elements have a low ionization energy than the alkaline earth metals? Because in 13th group elements, electrons are present, like 2 electrons are present in the s orbital and 1 is present in the p orbital. It means 3 electrons are in the valence shell. And in 13th group elements, the last shell is their p orbital. It means 1 electron is removed from the p orbital. But in case of alkaline earth metals, only 2 electrons are present in s orbital. 2 electrons are present in s orbital. It means it's easy to remove that 1 electron from the p orbital. Only 1 is present and we can fill maximum 6 electrons in the p orbital. And it requires less amount of energy to remove electron from this p orbital. So 13 group elements have a low ionization energy as compared to group 2, that is alkaline earth metals. So in the center there is a nucleus, number of shells are present around the nucleus, and in case of 13th group elements, 1 electron is removed from the p orbital. After this, like the 13th group elements, and those elements are boron, aluminium, gallium, indium and thallium. So if we next one is we compare their electron activity. Electron activity, what is electron activity? When there is a bond formed between the two different atoms or two different elements, and it is the when electron is shared between these two elements, it is a tendency of one atom to attract that shared paired electrons towards itself. And this electron activity depends upon the size. Generally smaller is the size and more is the electron activity. It means electron activity is directly proportional to size. And 13 group elements are more electronegative than group 1 and 2. Group 1 and 2 means alkali metals, and group 2 means alkaline earth metals. They have a more electronegativity than the 1 and 2 group. And generally it decreases like size. Electronegativity, there is again variation among the same group. If we compare between boron and aluminium, then electronegativity decreases. Why it decreases? Because there is increase in the size, and with the increase in size, electronegativity decreases because it is inversely proportional to size of an atom. But it increases from gallium to thallium. Why it increases? As size is also increases from gallium to thallium, because in case of gallium and thallium there is a poor shielding effect. Poor shielding effect means, like in case of boron and aluminium, s and p orbitals are present, and in case of gallium, indium and thallium, d orbital is also present. And due to the presence of this d orbital, that means जो shielding effect है that it is increase, it is s, p, d and f. In this order it increase. It is more in case of s orbital. So s and p are present in case of boron and aluminium. So with the increase in size, electron activity decreases. But after that, when we compare between gallium, indium and thallium, then electron activity increases because their size increases, but with the increase in size, that shielding effect it decreases. Due to the presence of poor shielding effect, electron activity increases from gallium, indium and thallium, and it decreases from boron to aluminium. Reason is same, because boron to aluminium size increases. But size also increases when we move from gallium, indium and thallium, but with the increase in size there is a poor shielding effect, and due to this the electron activity increases. Next one is their melting and boiling points. Generally, melting and boiling points are not regular in case of group 13th elements. Why these are not regular in 13th group elements? Because like boron has high melting points because its structure is crystallized structure. Crystallized structure means that atoms are present and they have a high melting points. Atoms are in the crystal structure, they are closely packed and it requires heat to break that bond. Bond is formed in the crystal structure and it has a high melting point. Next one is density. Density of this 13th group element is high than the group 2. 13th group elements are high in density because density is high because size is smaller. Due to the size small, the density is high of 13 group elements as compared to group 2. It means we are comparing it with the group 2nd, alkaline earth metals. Next one is their oxidation state. Generally, oxidation state is +3 of this group 13th elements. +3 means in this case 2 electrons from the s orbital and 1 from p orbital are involved in the bonding. So oxidation state is +3. But it +3 oxidation state is only more stable in case of boron and aluminium. It is not stable in case of gallium, indium and thallium. It means when we move down the group, +1 oxidation state is more stable and +3 oxidation state is less stable. Reason is because when we are moving down the group from gallium, indium and thallium, only the electrons which are present in s orbital are not involved in bond formation. Electrons which are present in the s orbital are not involved in the bond formation because only those which are present in the p orbital are involved in the bond formation, and in p orbital only one electron is present. So that's why their oxidation state +1 oxidation state is more stable when we move down the group, and +3 oxidation state is stable in case of boron and aluminium. 2 from s and 1 from p, these 3 electrons are involved in the bond formation. And after this, the rest of the properties we will do in the next session. Thank you.